Hello and welcome to Study Space. Today we will discuss the questions of mathematical physics that were asked in JEST 2019. Okay, so let us start. Okay, the first question is, let A be a Hermitian matrix and C and D be unitary matrices. So which of the following matrices is unitary? To solve this question, you need to know the following two properties of any unitary matrix. The first one is that the inverse of a unitary matrix is also a unitary matrix. And the second one is the product of unitary matrices is also a unitary matrix. Okay. Now see, out of these four options, A, C, and D all contains the matrix A or its inverse. Okay. Now A is a Hermitian matrix and it's not unitary matrix. Okay. But option B contains C inverse, D, and C. So it's a product of C inverse and D and C. Now by the first property, C inverse has to be a unitary matrix if C is a unitary matrix. Therefore, this product of C inverse, D, and C has to be a unitary matrix. So B is the correct answer to this question. It's a very straightforward question. Let's see the second question now. Consider a 2 by 2 matrix A is equal to 1, 13, 0, 1. And you're asked to compute what is A to the power 27. Whenever they ask these kinds of questions, you need to first calculate what is A square. Okay? Then you need to calculate what is A cube. Doing this exercise, you will come across some pattern. Okay? That pattern you have to recognize to tell what would be A to the power, let's say, n. Okay, so here it is asking A to the power 27. So let's calculate A square. It comes out to be 1, 2 into 13, 0, 1. Then when we calculate A cube, it comes out to be 1, 3 into 13, 0, and 1. Okay, so you see there's a pattern going on here. Therefore, if you let's say compute A to the power 27, it has to come out 1, 27 into 13, 0, and 1. And 27 into 13 is 351. Therefore, A to the power 27 will be 1, and 351, 0, and 1. Okay. So, in this question, D is the right answer. Okay. The third question is, the Euler polynomials are defined by 2 into e to the power x into s divided by e to the power x plus 1. And this can be written as a series, or let's say polynomial series, as summation of n equal to 0 to infinity en of s into x to the power n divided by n factorial. And you're asked to calculate, using this information, what is the value of e5 of 2 plus e5 of 3. Okay. Now to solve this question, you don't need to really know what are Euler polynomials, what are their properties, and so on. Okay, those are not required here. You simply have to use some property of the exponential function that you already know to manipulate this function such that you're able to write it as a series. And then you need to compare that series with a given series and find out en of s. Okay, so let's see how do we do it. Now you know that for x greater than 0, e to the power x is always greater than 1. To see this, you just need to plot e to the power x, and you will see that e to the power x is always greater than 1 for any positive value of x. Okay, now using this, we want to somehow turn this expression on the left hand side to a series form. Okay, so how do we do it? Now see, 2 into e to the power x into s divided by e to the power x plus 1 can be written as 2 into e to the power x into s divided by, we take out the common factor e to the power x, and we can write then 1 plus e to the power minus x. Okay, now the denominator and the numerator can become 2 into e to the power x into s minus 1 times, now this 1 plus e to the power minus x in the denominator can be written as 1 plus e to the power minus x to the power minus 1. Okay, why are we writing like this? We want to use the fact that e to the power x is always greater than 1, and therefore e to the power minus x will always be less than 1. And since e to the power minus x is always less than 1, we can use binomial expansion, okay, for this particular term. So using the binomial expansion, what do we get? We get this 2 into e to the power s in minus 1 into x into the binomial expansion of 1 plus x to the power minus 1 can be written as 1 minus x plus x square minus x cube plus x to the power 4 and so on. So with alternate signs, you have x, x square, x cube, x to the power 4. Okay. So here in place of x, you have e to the power minus x. See. Therefore, the binomial expansion gives you 1 minus e to the power minus x plus e to the power minus 2x minus e to the power minus 3x and so on. Okay. Now you keep 2 outside and multiply e to the power s minus 1 into x with all the terms in the bracket. Okay. And now you write all the exponentials in their series form. You know the series form of the an exponential? It's e to the power alpha x can be written as 1 plus alpha x plus 1 by 2 factorial into alpha x the whole square plus 1 by 3 factorial into alpha x the whole cube and so on. Okay, this is a general thing that all of you must be knowing. So when you write all these exponentials in their series form, this becomes summation of n equal to 0 to infinity s minus 1 to the n into x to the power n divided by n factorial. This is the series form of e to the power s minus 1 into x minus s minus 2 to the power n into x to the power n divided by n factorial plus s minus 3 to the power n x to the power n divided by n factorial minus so on. Okay. Now this is a series form, and this can be compared with a series given in the question, which is summation of n equal to 0 to infinity en of s into x to the power n divided by n factorial. Okay. Now you see here, when we compare these two series, you can write e to the e of s as 2 into s minus 1 to the power n minus s minus 2 to the power n plus s minus 3 to the power n and so on. Okay, we're just comparing the two series. So x to the power n divided by n factorial is in all the terms. Therefore, s minus 1 to the power n minus s minus 2 to the power n plus s minus 3 to the power n. That whole thing must be equal to en of s. Now, if you put s is equal to 2 and n is equal to 5, you get en of s as 2 into 1 to the power 5 minus 0 to the power 5 plus minus 1 to the power 5 and minus and so on. Okay, and if you put 3 in place of s, you get the second line that is written here. Okay, now if you add these two, you see that all the terms cancel off with their adjacent neighbors. This 1 to the power 5 is in e of 2 and minus 1 to the power 5 is in e of 3. In the same way, minus 1 to the power 5 is in e of 2 and minus of minus 1 to the power 5 is in e of 3, and therefore all these terms cancel off, and what remains is just 2 into 2 to the power 5, which is 2 to the power 6, and therefore e of 2 plus e of 3 for n is equal to 5 is equal to 64. Okay, so this is the answer to this question. Let's look at the next question. What is the angle in degrees between the surfaces y square plus z square equal to 2 and y square minus x square equal to 0 at the point 1, minus 1, 1? Okay, so see, whenever you are told to find out the angle between two surfaces, what you have to do is to find the angle between the normals to the two surfaces. Why? The angle between two surfaces is actually equal to the angle between the normal to the surfaces. Okay. What is the direction of the normal to a surface? It's actually along the direction of gradient of the surface. So if we calculate the gradient of these two surfaces at the given point, that is 1 comma minus 1 comma 1, what you get is gradient of f1 to be 2y j cap plus 2z k cap. And when you put 1 comma minus 1 comma 1 in this, what you get is minus 2j cap plus 2k cap. Now this is not a unit vector. Okay, what we want is the unit vector, because we don't want the magnitude to uh, affect the calculations that we want to do with these normal vectors. Okay, so the unit vector along this direction would be minus j cap plus k cap divided by root 2. Similarly, if you want to calculate the gradient of the second surface, you would get 2yj cap minus 2xi cap. Okay, and then again you put 1 comma minus 1 comma 1, you would get the n2 unit vector to be minus I cap minus j cap divided by root 2. Okay, now the angle between two vectors, two unit vectors specifically, can be calculated as cos inverse of n1 dot n2. And here if you calculate the dot product of n1 with n2, you would get, it comes out to be cos inverse of 1 by 2, which is 60 degree. Okay, therefore angle between the surfaces is 60 degree. The next question says, let R be the position vector of a point on a closed contour C. What is the value of the line integral R dot dr? This is a fairly straightforward question, very simple. So it is asking you to calculate the line integral of R dot dr. Okay, along this contour, along any contour. So I've drawn a contour here, the regular shape. But this contour is a closed contour. That is important. If it is a closed contour, you can use Stokes' theorem to calculate the line integral. And what Stokes' theorem says? It says that R dot dr should be equal to del cross R dot dA. Okay, dA is the infinitesimal area of the surface. Okay, that means the area inside this contour, we are calling it A. Okay, now this is by Stokes' theorem. And since curl of R is 0, therefore the line integral of R with dr has to be 0. Okay, that's a very straightforward question. Now let us see the next question. Consider the function f of x comma y is equal to mod of x minus I times mod of y. In which domain of the complex plane is this function analytic? Okay, see, one of the simplest methods to say whether a function is analytic or not is to check whether the function can be written as a polynomial in Z, where Z is a complex number which is equal to x plus iota y. Okay, so if any function can be written, that is any complex function can be written as a polynomial in Z, then it is certain to be analytic. Okay, and the second point that you need to know is that if a function contains Z bar, it is non-analytic. Okay, so now let us do this question. So in the first quadrant, f of x comma y can be written as x minus iy. Okay, and x minus iy, as you know, is z bar. And I said you, whenever a function contains z bar, it has to be non-analytic. So in first quadrant, the function is non-analytic. In second quadrant, you can write f of x comma y as minus x minus iy, which is minus z. Now see, in the second quadrant, f of x comma y can be written as a polynomial in Z, a polynomial of order 1. So it has to be analytic in second quadrant. In third quadrant, you can write f of x comma y as minus x plus I into y. And this is minus z bar. Again, because of the presence of z bar, it has to be non-analytic in this domain. And in fourth quadrant, you can write f of x comma y as x plus iy, which is z. So again, it is a polynomial of order 1 in Z. Therefore, it has to be analytic in fourth quadrant also. Hence, the function f of x comma y is analytic in second and fourth quadrants. Okay. Let us see the next question. Consider a function fx is equal to pk of x into e to the power minus x to the power 4 plus 2x square, and the domain is x belonging to minus infinity to plus infinity, where pk is any polynomial of degree k. Then what is the maximum possible number of extrema of the function? See, you need to calculate the maximum number of extrema of the function, which means what is the maximum number of zeros that f dash x can have. Okay, this is what the question is asking. So what do we do here? We first find out f dash x. Okay, so f dash x can be found to be pk dash x minus the differentiation of x to the power 4 plus 2x squared is 4x cubed plus 4x into pkx. The whole thing will be multiplied by the power minus x to the power 4 plus 2x square. Okay, now see, the e to the power thing can never be 0. An exponential function can never be 0. Okay, therefore, if at all f dash x has to be 0, the zeros have to come from the term in the parenthesis. Now, the question says that pk of x is a polynomial of degree k. And here see, 4x cubed plus 4x is multiplying pk of x. That means x cubed adds an order of 3 to pk, which means that the term in the parentheses is a polynomial of degree k plus 3. Now, why are we not looking at pk dash? Because if pk is of order k, pk dash has to be of order k minus 1. So that is an order which is lesser than the order of x cube into pk of x. Okay, and we need to only look at the highest power of x that can occur in this, because that will decide the degree of the polynomial, and the degree of the polynomial decides what is the maximum number of zeros that it can have. Okay, this is what the fundamental theorem of algebra says. So since the term in the parentheses is a polynomial of degree k plus 3, therefore f dash x can have a maximum of k plus 3 zeros. Okay, and therefore the function can have a maximum number of k plus 3 extrema. Okay, now let us look at next question. It asks you to calculate an integral involving a Dirac delta function. So minus infinity to plus infinity, integral of dx into del of x square minus pi square into cos x. Okay, now see, whenever this kind of integral is asked, which is of the form dx into del of some gx into fx, the general formula for these kinds of integrals is summation of I into f of xi divided by modulus of g dash of xi, where xi are nothing but the zeros of gx. That is, xi are the points where gx is equal to 0. Okay, therefore you need to calculate first what are the points at which x square minus pi square is 0. So if you do that, you will get x is equals to plus minus pi. Okay, now using this formula, you can easily see that this integral will be equal to cos of minus pi divided by modulus of g dash xi. Now g is x square minus pi square, therefore g dash will be 2x. So 2x has to be evaluated at minus pi, therefore 2 into minus pi, and the modulus of that will give you 2 pi. Okay, similarly, for x is equals to pi, you will have a term cos of pi divided by 2 pi, and both these terms will together give you minus 1 by pi. Okay, therefore the integral has a value of minus 1 by pi. Okay, let us move on. Which one of the following vectors lie along the line of intersection of the two planes? X plus 3y minus z is equal to 5 and 2x minus 2y plus 4z is equal to 3. The two planes are given and you need to find out which one of the given vectors um, lie along the line of intersection of the two planes. See, if a vector lies along the line of intersection of two planes, it means that that vector has to be contained in both the planes because line of intersection belongs to both the planes. And therefore, that vector which lies along the line of intersection of the two planes has to be contained in both the planes. And since the vector is in both the planes, therefore the vector has to be perpendicular to the normals of both the planes. Okay, so this is what we will be using to find out which one of these vectors is actually lying along the line of intersection of the two planes. Okay, we know that the normal to a surface is actually along the gradient of the surface. Therefore, the normal to the plane will be along the gradient to the plane. So let's find out the gradient first. So the gradient of x plus 3y minus z minus 5, this is the surface. Actually, the first surface will be I cap plus 3j cap minus k cap, and the gradient of the second surface will be 2i cap minus 2j cap plus 4k cap. Okay, now let us check which of the given vectors is perpendicular to both these gradient vectors. Okay, which is the necessary criteria for it to lie along the line of intersection of these two planes. So let us check for the second option, 10i cap minus 6j cap minus 8k cap. So if you check for that, what you would get is if you take the dot product of v with the gradient of f1, you would see that it comes out to be 10 minus 18 plus 8, which is equal to 0. And if you do the same thing with del of f2, you will get 20 plus 12 minus 32, which is again 0. What does it tell you? It tells you that v is perpendicular to both gradient of f1 and and gradient of f2. Okay, and therefore this vector, that is 10i cap minus 6j cap minus 8k cap, has to lie along the line of intersection. Okay, that's a question on probability. It says a person plans to go from town A to town B by taking either the route r1 plus r2 with probability half, or the route r1 plus r3 with probability half. Okay, you need to look at this figure and understand what's going on. So the person starts from A, okay, and it travels either by r1 plus r2 to B or r1 plus r3 to B. Okay, each of these routes has a probability of half to be taken by the person. Okay, further, there is a probability that of 1 by 3 that r1 is blocked, a probability 1 by 3 that r2 is blocked, and a probability 1 by 3 that r3 is blocked. So what is the probability that he or she would ultimately reach town B if he starts from town A? Okay, so how do we do it? It's very simple. So see, to ensure that the person is able to reach town B if he starts from town A, we have to first ensure that R1 is not blocked. Okay, but the question says that there is a probability of 1 by 3 that R1 is blocked. Therefore, there is a probability of 2 by 3 that R1 is not blocked. Therefore, to ensure that R1 is not blocked, we have to take the probability 2 into 3 times. Now he takes either R2 or R3. Okay, now let's suppose he takes the root R2. If he takes the root R2, what's the probability of him taking the root R2? It is 1 by 2. It's given in the question to be 1 by 2. But there is a probability of 1 by 3 that R2 is blocked. Therefore, we need to ensure that R2 is not blocked. And therefore, we need to multiply by 2 by 3 again. Okay. So, if we are ensuring that R1 is not blocked and R2 is not blocked and the person is taking the root of R1 plus R2, he would be able to reach B. The another way that he would be able to reach B is that R1 is not blocked, which means 2 by 3 probability, and he takes R3 root, probability of that is 1 by 2, and that R3 is not blocked, the probability of that being 2 by 3. Therefore, the probability that the person reaches B if he starts from A is actually 4 by 9. Okay, so this is the last question we'll be dealing today. It says consider two n by n matrices A and B such that A plus B is invertible. Now we are defining two matrices C and D. C is equal to A into A plus B inverse into B, and D is equal to B into A plus B inverse into A, which the following relations always hold true if these two definitions are given to you. Now to solve this question, first of all, you need to assume something. You need to assume that A and B are invertible matrices. Okay, because if you don't assume A and B are invertible matrices, then you won't be able to define C inverse. Okay, but to define C inverse, you have to assume that A and B are invertible matrices. Okay, but in the question, it is given that A plus B is invertible. The question says nothing about A and B being separately invertible. Okay, that's a technical fault in the question. Actually, it should be given in the question itself that A and B is invertible, so that we don't have to assume anything from our side. But nevertheless, for the sake of this question, we have to assume that A and B are invertible matrices. Otherwise, you won't be able to calculate C inverse. And in one of the options, there is C inverse written there. So it's actually implicitly assuming that A and B are invertible matrices. So let us assume that A and B are invertible matrices. Then C inverse can be calculated. And C inverse would be what? See, the inverses are calculated like this. If you take inverse of, let's say, A into B, okay, the inverse of A into B would actually be B inverse into A inverse. Okay, so the order changes in the inverse. So C inverse would be B inverse into A plus B inverse to the inverse. Since A plus B inverse to inverse will give you A plus B, okay, into A inverse. So C inverse becomes B inverse into A inverse plus B inverse into B into A inverse. Therefore, C inverse becomes B inverse plus A inverse. Now let's calculate D inverse. If you calculate D inverse, you would get A inverse into A plus B into B inverse. And here, therefore, D inverse will be equal to A inverse into A into B inverse plus A inverse into B into B inverse. And therefore, D inverse also comes out to B inverse plus A inverse. So from 1 into you see that C inverse is actually equal to D inverse. Okay? But we know that inverse of matrix is unique. And therefore, if C inverse is equal to D inverse, C has to be equal to D. Okay? The first option is the right answer to this question. Okay, so I hope that I've given you a detailed understanding of the questions that were asked in mathematical physics portion. Okay, I'll be coming up with more videos. Thank you.